This is lab 3 for physics 1 about black holes. The purpose of this lab is to generate a unique star trajectory linked to my email address to generate the position data of a star. Then the mass of the black hole will be found using the results of the analysis of the data. And lastly, we will simulate the motion of a spaceship, accounting for gravitational forces of the planet and black hole. And we will use Newton's second law to predict the motion of the planet and spaceships to find the initial velocity. So here we're using Newton's second law of motion, the law of universal gravitation, the momentum principle, and the parallel and perpendicular components, which again tie into Newton's second law. So our initial conditions are the seed, which only needs my email address. That is how the unique trajectory is created. We have the gravitational constant, and all of these are listed below. So the gravitational constant, the star mass given by the lab, the change in time, which we know that the time between the data points to the trajectory is 1 day. So we set the time to be 86,400 seconds, which is equivalent to 24 hours. And our time for first observation is 0 because we start at 0. So for the second part of the lab, for the spaceship, we apply our physics principles here. So we find the gravity on the planet by the black hole, the gravity on the planet by the spaceship, and then the net force on the planet. So you can see here we use our universal law of gravitation and then our position update formula. And same thing down here, position update and the force on the ship. So that will be the force on the spaceship by the black hole, the force on the spaceship by the planet, and then the net force. So same here, we apply the position update formula and the universal law of gravitation. And then down here, we can apply Newton's second law and the position update formula to make this planet and spaceship move in this sense. So with the code, and here we see the planet velocity. So the final velocity equal to the initial velocity, plus the net force over the mass times the change in time. And then we can use similar formula with Newton's second law to calculate the ship's velocity as well. And then from that, our results for the first part of the lab is that the star travels in an oval trajectory with net force pointing in 3 different directions. So the F net arrow will be pointing inward, our parallel arrow will be pointing along the trajectory of the star, and our perpendicular arrow is pointing towards the center of the circle. And the black hole mass is calculated to be around 9 times 10 to the 33rd power kilograms. And we find the average mass here by putting all of our data that is generated from the code, which I'll show you in a second, in a spreadsheet and finding the average mass. So here our formula is the average of all of these values. And these values are created through the code for the orbit. So here we can see these arrows, one pointing towards trajectory, one towards the center, one towards the planet, right? And give it a second to generate our values. And then we can see here at the end also our F net, F parallel, and then F force hook. Net force for the parallel component, and then the net force for the perpendicular component. And then for the results for the second part of our lab, obviously we do have that's for the first part, we have the net forces. And then for the second part of the lab, we calculate the velocity. So we can plug in numbers. We can plug in values for X and Y for our ship speed to find the velocity that ends up working for this code. So here we have the ship speed. And if we run this program, we can see how many meters away and how many minutes. So what does this mean? The rate of change and momentum are the same mathematically in this scenario, but one can actually be observed and the other cannot. Force is not a quantity that can be deduced purely from observation, so to compute the change in momentum over change in time, we need mass, velocity, the time interval, and then the net force sums all of the forces acting on an object, which are more challenging to observe. So for the what if question, how to find the initial velocity, the initial velocity has both X and Y components. It's based on the force it takes for a black hole to maintain the circular orbit. We can use the code to calculate this, and for mine, I got about, in the X direction, it would be about 10 to the 10th power, and then in the Y direction, it would be about 2.8 times 10 to the 10th power, and obviously there's no Z component. And then possible sources of error are really just rounding. So the velocity values that I rounded, or any of the other values that I rounded in my code, those can affect the trajectory. And then the formulas, the speed and gravity formulas use constants that are also rounded and approximated. So those can create sources of error. The sources of error are minimized because we are using code to run a simulation. So definitely a simulation is more accurate than in our previous labs where we tried to use like tracker, things like that, where we have to manually adjust it. So this is more accurate than that, but we still have some rounding and formulas that might change things. Thank you.